2, 3 polynomial and rational functions starts with long division, okay? And obviously it's long for a reason. It's called long division. Can we get the air headphones out? Thank you. It says arrange the terms, both the dividend, which is what you're dividing into, by, and the divisor, which is what you're dividing by. So dividend goes inside and divisor goes outside. Or it's dividend over divisor. Okay. So we check both of them to make sure they're in descending powers. So the highest exponent down to none. And if there's any terms missing, we plug in placeholders. So if you have an x to the second and then an x and you're missing, or sorry, let's say you have an x to the third and an x and you're missing the x to the second, you plug in a 0x to the second. You have to plug in a placeholder. So if missing terms, then we plug in a 0x to whatever that power is. So if the highest exponent is x to the third, I have to have an x to the third, an x to the second, an x to the first, and a constant, okay? On both the divisor and the dividend, so you have to check both. Then you divide the first term on the outside into the first term on the inside, or first term on the inside by the first term on the outside, okay? Just like you would do long division with a numeric value. You multiply those terms out by whatever's on the outside. This says subtract the product from the dividend, which is the same thing as changing your sign and multiplying. Changing your sign and add, sorry. And people tend to make some weird mistakes when you subtract negatives, so I would strongly recommend that we change the sign and then add instead. And then you bring down the next term and you repeat that process until the power on the outside has become bigger than the power you're dividing into. That's how you would know to stop. Okay, we don't do negative exponents here. And you will write your answer as quotient, which is what's at the top, plus remainder over divisor. So whatever's at the top is your quotient. At the end, this would be my quotient. Whatever's the remainder goes over what's on the outside of the divisor. So it follows the same pattern as long division with numeric values. You're just going to have variables in here. Now, long division can be done every single time. Synthetic division, which we're going to go over in a little bit, can only be done certain times. So long division all the time. Synthetic only some of the times. All right, so here's example 1. It says divide 9x squared plus 6x plus 5 by 3x minus 2. So I'm going to take what I'm dividing into, which is this 9x squared plus 6x plus 5. I'm going to make sure it's in order of decreasing degree, so highest exponent is to the second. Then there's 1 to the first, and then there's none. So I don't have to plug anything in. If there was anything missing, I would then plug in a placeholder. Then divide by it, 3x minus 2. That goes on the outside. And then I only focus on first times first. So whatever I'd have to multiply 3x by to get to 9x squared is what I put over it. What would I multiply 3x by to get to 9x squared? 3x. And then I multiply that times both the terms on the outside. So it gets multiplied by 3x first. I get 9x squared. And then it gets multiplied by negative 2, and I get negative 6x. With me so far? Okay, then we change our signs and add. You can subtract, it's the same thing, but again, I have found that people make some weird mistakes when you start subtracting negatives. So my advice is change your signs here and then add these. If you've done it correctly, the first column should cancel out. Positive 9x squared and negative 9x squared cancel out. And then I have positive 6x and positive 6x, which would be a 12x. And then I bring down the next term. And I repeat that whole process. Now it's first and first. So what do I have to multiply 3x by to get to 12x? Good. Positive 4 goes here. And I multiply it first by 3x, so it's 12x. And then by negative 2, so it's minus 8. And then we change our signs. This cancels like it should. And I get 13 at the end. There is no way to multiply 3x by something to get to 13. When the exponent on what you're dividing into is smaller than what you're dividing by, you're done, okay? That is my remainder. So my quotient, which is 3x plus 4, we add to it the remainder, which is 13, over the divisor, which is 3x minus 2. Questions so far? Yep.
If there was no divisor, the answer would be 3x plus 4.
If there, like no remainder, you mean? Yes. Yeah. All right. What's different about this one? This time you're missing a term, right? So if I look at this, the highest exponent is x to the third, and then it's x to the first, which means you're missing your x squared. I plug in a positive or negative. Honestly, it doesn't matter, but I tend to do positive. X squared, and then continue the rest of it. So you have to have a term there for each exponent from decreasing degree from the highest down to none. Then I divide by, I also check the divisor, and it is in order of decreasing degree. There's nothing missing, so that goes on the outside. And I repeat, first into first. So what do I have to multiply x squared by to get to x to the third? Good. I multiply it times all three. So x times x squared is x to the third. X times 5x is positive 5x squared. X times negative 3 is negative 3x. Then we change our signs and add. The first column should cancel. Positive 0 and negative 5 is negative 5x squared. Positive 3x and positive 3x is positive 6x. And then I bring down the next one. Now I want to multiply x squared by something to get to negative 5x squared, which would be negative 5, and I multiply it times all three terms. Negative 5x squared, negative 25x, positive 15. Change your signs. The first column cancels. 6x plus 25x is 31x. Negative 2 and negative 15 is negative 17. And that whole thing is my remainder. So my quotient is x minus 5 plus 31x minus 17 over x squared plus 5x minus 3. Questions on that one? All right, the division algorithm. So there's a bunch of little tricks and applications in this section. And this one says if the remainder is 0, then we say the divisor divides evenly into the dividend, and the divisor and the quotient are factors. All right, so in like normal speak, all this means is that if I divide something into the dividend and my remainder is 0, then whatever I divided into it is called a factor, okay? If you think about this in terms of like a numeric value, if I asked you is 2 a factor of 10, what would you be looking for? How do you know it's a factor? If it divides evenly into it, right? Does 2 go evenly into 10? Yes, because it has a remainder of 0, it's a factor. So it's the same concept. If x squared divides, or x squared, let's say x squared minus 25 divided by x plus 5, results in a 0 as its remainder, then I say x plus 5 is a factor of x squared minus 25. That's all it means, okay? A factor or a linear factor is written like this, which we're going to get back to in a little bit, okay? So a solution would be just negative 5 on that one. But if it said factor, you put it behind the x, okay? That's how you would show something as a factor of something. All right, next up is synthetic division, okay? I know I'm a nerd and I teach math for a living, but I think synthetic division is fun. Like, not I'm going to do this in my spare time fun, but like more fun than long division. I think it could be an Olympic sport. Yes. All right, so we're going to synthetic. So synthetic is easier because it's faster. We eliminate all the variables. You are going to arrange your polynomial in descending powers with 0 as a coefficient for any missing terms. Same exact first step as long division. Make sure it's in decreasing degree. Make sure there's a term there, and if there's not, you're plugging in a 0 in its place, okay? Then if your divisor is x minus c, and it could be x plus c or x minus c, it doesn't matter, okay? But it cannot be x squared. That's the difference. It can only be x to the first power. You're going to write the opposite of what follows x on the outside. So you'd put c out here. Then you list all your coefficients and the constant at the end. You bring down the first term. You multiply it by what's on the outside and put it in the next column. And then you add it. And then you multiply it by what's on the outside. You put it in the next column and you add it. And you repeat that until you run out of columns, okay? At the end, whatever's in this bottom section, the very last term is your remainder. And then there's two ways to look at it. Work up from there. The next one would be your constant. The next one would get x. The next one would get x squared. The next one would get x to the third, and so on until you run out of spots, okay? Or work left to right, where the first exponent has to be one less than what you divided into. So if I'm dividing into x to the fourth, then the first exponent is x to the third, and then we go x to the second, x to the first, and no x, okay? Do we remember this? Yes. Better than long division? Yes. Okay. So it looks like this, and it just says divide, okay? If it says explicitly synthetic, then obviously you can use synthetic. But as long as what I'm dividing by does not have a squared, it's only x plus or minus a number, I can use synthetic, okay? So I'm going to look at my dividend. I'm going to make sure that it's in decreasing degree order. Nothing's missing. Is that happening? What's wrong this time? I'm missing an x squared, so I'd add in a 0x squared. Now I list all my coefficients. 5, 0, 6, 8. I draw the long bar. Some people draw it this way. Some people draw it that way. You do whatever you want, as long as you know what it does. I put the opposite of what follows x on the outside, so this is negative 2. I bring down the first term. I multiply by what's on the outside. Negative 2 times 5 is negative 10. It goes in the next column. I add them. 0, negative 10 is negative 10. I repeat the process. Multiply by what's on the outside. Negative 2 times negative 10 is 20. I add them. I get 26. I multiply by what's on the outside. Negative 2 times 26. Negative 52. I add them. Positive 8, negative 52 is negative 46. No. Negative 44. This is my remainder. Then as I move left from there, the 26 is the constant. The 10 gets the x to the first. The 5 gets the x to the second. And we write it the same way. 5x squared minus 10x plus 26. Now, instead of writing plus a negative 44 over x plus 2, we take that negative from the numerator and bring it out front. So this changes to minus 44 over x plus 2. Questions on that one? All right, you do this one. All right, so 4 goes on the outside because it follows the x. So like if that just, which we'll see in a minute, if it just said like f of -4, you keep the sign. But if it says x minus 4, that's when you change the sign. So the 4 goes on the outside. Then we keep all the coefficients. I bring down the 3. I multiply it by 4. I put it in the next column. I add it. I multiply it by 4. I put it in the next column. I add it. I multiply it by 4. I put it in the next column. I add it. My remainder is, these are all positive this time, but my remainder is positive 132. The 35 stays as 35. The 7 gets the x. The 3 gets the x squared. So I'd get 3x squared plus 7x plus 35 plus 132 over x minus 4. Raise your hand if you got it right. Good. Questions? Okay, so here's the application of this. We're going to use synthetic in a lot of different ways. This is the first way. And this is called the remainder theorem. The remainder theorem basically just says, if I take a polynomial and divide it by a dividend, whatever the remainder is the exact same thing I would have gotten had I plugged that number in for x. So when you see something like, if I had given this to you before today, here's f of x, find f of 2, what would you have done? I would have taken 2 and plugged it into all the x's, and then I would have simplified, yes? Now what this is saying is what you can also do is take that 2, put it on the outside, not changing its sign because that is saying x is 2, not x plus 2. So we keep x as 2 on the outside. I do synthetic division, and the remainder of it is my answer. So when it says use the remainder theorem to evaluate f of 2, that's what it means. Okay, use synthetic division. Go ahead, work through your synthetic division, and whatever the remainder is your answer. Just the remainder, okay? You don't need to put your quotient and your remainder, just the remainder. So it looks like this. Use synthetic division to find the remainder theorem to find the indicated function value. F of x equals 3x squared minus 5x plus 1, and f of 2. So what goes on the outside? 2. Okay, what do I have to do with this before I can write out my coefficients? Yeah. Good, there's no x, so I put 0x there. Then I do 3, -5, 0, 1. I bring down the 3, multiply it times 2, put it in the next column, add it, multiply it by 2, put it in the next column, add it, multiply it by 2, put it in the next column, and add it. And 5 is the answer to f of 2. Just 5. So f of 2 equals 5, okay? You can give me just 5, or you can write it as f of 2 equals 5. But do not give that whole quotient. Questions on that one? Yep. And the test will, I didn't finalize it yet, but it will most likely, the wording will be that. Use the synthetic division and the remainder theorem to find it. So you can plug in to check if you want, but I'm looking for the work for the synthetic division. All right, the factor theorem says that if you have a polynomial and then you do f of a value and that answer is 0, which means your remainder would be 0, then x minus c is a factor. So we talked about this a couple slides ago. And the reverse, if they say x minus c is a factor of something, then I would know that if I did f of that value, my remainder would be 0. And the way you'll see these applied is it will literally say, here's your function. Given this one is a factor, find the remaining. So you're going to take the factor they give you, do synthetic division to reduce it a degree. So if it was cubed, it would then become quadratic. And then from there, you'll either factor or use the quadratic to find the remaining roots. Or use quadratic, which is negative b plus and minus the square root of b squared minus 4ac all over 2a. Good. So if it's factorable, obviously I would recommend factoring it because it's going to be faster. God bless you. But if it's not factorable, as long as it is quadratic, then you can find the remaining ones. All right, it would look like this. Solve the equation x to the third minus 7x plus 6 equals 0, given that 2 is a 0. So we'll either say 2 is a 0 or we'll say x minus 2 is a factor, and those mean the same things. Because if it's x minus 2, then my answer is 2, okay? So 2 goes on the outside. Is anything missing?
Yes.
Yep, what's this time?
X squared.
Good. 0x squared is missing, so it'd be 1, 0, negative 7, positive 6. Bring down the 1, multiply by 2, put it in the next column, add it. Multiply by 2, put it in the next column, add it. Multiply by 2, put it in the next column, add it. So if this was not 0, you did something wrong. It told you it's a factor. If it's a factor, that last one should be 0. Your remainder should be 0. Then the negative 3 is the constant. The 2 gets the x. The 1 gets the x squared. So the quotient here would be x squared plus 2x minus 3. We call that reducing it a degree. We just went from x to the third to x to the second. We literally reduce it a degree. Every time you find a root and you divide into it, you're reducing it a degree. Now I want to see, is this factorable, because I want to keep going. So are there factors of negative 3 that sum to 2? What are they?
3 and negative 1.
Good. Positive 3, negative 1. And then I want to split and solve these, because if either is 0, then my product is 0. And I get my remaining roots or zeros. What did my question ask for? To solve it. What's the answer to a solving equation? How would you show what the solutions were? X equals, and it's all three of them. The one they gave you at the beginning, the negative 3, and the positive 1. Pay attention to web sign. I can't remember if it tells you to put them in order or not. If it was, obviously it'd be negative 3, 1, and 2. If it's just separate with a comma, then you're just separating with a comma. But all three have to be there, including the one they gave you. Questions on that? All right, now we just take it a step further. It starts the exact same beginning part. Verify the given factors. Find the remaining factors. Use the result to write the complete factorization and list all the zeros. So obviously it's asking for more at the end, but it's also giving you what this time? How many factors are there? 2, okay? So the way we do this is we're going to use the first one to reduce it from x to the third to x to the second. If we need the second one, we're then going to use the second one to reduce it from the second to the first, and then you have found all three. So I'm going to start with the first one. I put negative 2 on the outside because it's an x plus 2, which means the actual root would be negative 2. There's nothing missing here, so 2, 1, negative 5, 2. I bring down the 2. I multiply it by what's on the outside. I add it. I multiply by what's on the outside. I add it. I multiply by what's on the outside. I add it. If that wasn't 0, I did something wrong. So that's verify the given factors. I just verified that one by showing the remainder 0. Now, I can either go back to the original one and use x minus 1 or positive 1 on the outside and show that it's also 0. Or I can take the quotient I just got from here and now use that as your coefficients and then use the positive one on the outside. Bring down the 2, multiply it, put it in the next column, add it, multiply it, put it in the next column, add it. Now the benefit of that is what's left is a linear factor. So all I have to do is set this equal to 0, and I get my remaining root without having to factor this. If I had factored that, I would have gotten x minus 1 and 2x minus 1. I would have gotten those 2 roots. But if they give you 2, you might as well use it to reduce it another degree. Yep. On the outside comes whatever's after this, but the opposite of it. Because you would be solving those for, you'd set them equal to 0. I picked -2 first, and then I did 1. You could have done that in either order. Yep. All right, now look at what it says. Find the remaining factors. So we just found factors are in parentheses. So factors are like this. B would be x plus 2. Actually, the remaining factor is just 2x minus 1. That's your remaining factor. C says use your results to write the complete factorization. This is all 3 factors. So x plus 2 times x minus 1 times 2x minus 1. And D says list all the real zeros of f. So I get -2 and +1 from the factors that were given to me, and +1/2 from the last one I found. Yep. You got to take the factors they give you and use synthetic division to reduce it a degree. So like we did it to reduce it a degree, right? We took -2, we put it on the outside. We use synthetic division, and you should get 0 as a remainder here. If not, something's wrong. And then this is what we call a reduced degree. So we took it from x to the 3rd to x to the 2nd. If I didn't have another factor, I would have just factored that, and I would have found the other 2. But they gave you a second factor this time. So then I took the second factor, which was -1 or +1, and I put it on the outside, and I used my reduced degree one here. And then I divided synthetically. I got 0 again, as I should have. And then the last thing here is the remaining factor. So if they only give you 1, you're going to be able to factor what's left. If they give you 2, then you use the second one to reduce it again, and you can find the last one. Just be careful, and you make sure you answer all those parts, because it's going to literally say all those parts for some of them. All right, we're going to stop here. We're going to do the rest tomorrow, but your homework assignment is just this part. It is due tomorrow, okay? I didn't do one assignment and then you split it between the days. It is 1 today and 1 tomorrow. So on WebAssign, you'll see it starts in the beginning. It says use long division, use synthetic division, and then it wraps up at the end with something like this. There is a question that says use the remainder theorem to evaluate f of this and f of this and f of this. And some of them, those numbers get big. Feel free to use a calculator for that stuff, okay? They won't be huge for your test, but you will not have a calculator on those, okay? Just be careful.